How are you, my friends? This is Calculus 1 solved questions, simple curve sketching. This is part 1, and you can expect also part 2. Question number 1, sketch the graph of this function f of x is equal x cubed minus 12x. This is the polynomial function of degree 3. So the solution we start with, we find the end behavior. This is case number 3. You can look at lecture 18 in the calculus 1. N is odd, this is 3, and the leading coefficient is positive. So the end behavior will be similar to x cubed. Let's find the derivative here. F prime of x will be 3x squared minus 12. Take 3 outside, then you have 3 times x squared minus 4. This is the difference between two squares, x plus 2 and x minus 2. Now the critical values, the values where f prime is equal to 0. So there are two values there, x equals 2 and x equals minus 2. The x-intercept, put y is equal to 0. So x times x squared minus 12 is equal to 0. Then we have three values. X will be 0, or x will be plus or minus square root of 12. 12 is 4 times 3, so it will be plus or minus 2 square root of 3. We can see now the table of signs on the next slide. So we have the x-intercept, three values, the critical, x equals 2 and x equals minus 2. See, the minus 2 now and the 2 are in the critical values. So we have the factors x minus 2, x plus 2. Take a number between minus infinity and minus 2. This will be negative and negative. When you multiply, you get positive. F prime is positive, means f of x is increasing. F prime is negative here between minus 2 and 2, so f will be decreasing. F prime is positive after 2, so f will be increasing. So increasing, decreasing, we have a local maximum at minus 2. From where we get the 16, replace minus 2 in the function here. Minus 2 all cubed, minus 12 times minus 2 will be 16. And at 2, we have a local minimum. Replace 2 in the function, then you get minus 16. This is the graph. And the f is increasing on this intervals. F is decreasing on this interval minus 2 to 2. Question number 2, we have nice function here, f of x, x minus 1 all squared times x plus 2 all squared. Now you can try it yourself, and if you are ready, you can see the solution. If you multiply, there is no need to multiply here, but if you multiply, you will get x to the power 4, which is even. And the leading coefficient here is 1, because x squared times x squared will be x to the power 4. This is the highest power. So the leading coefficient is positive. The degree is even, 4. So this is up to the right, up to the left. This is case number 1. You can see that in lecture 18. Now to find the derivative, look here at this nice question. This is a product rule, lecture number 7. Product rule, you remember the rule, it will be u prime v plus v prime u. So find the derivative of the first, 2x minus 1 power 1 times the same v here, x plus 2 squared, plus the derivative of the second here, 2x plus 2 power 1 times the first one, x minus 1 squared. Now what can we do? We take x minus 1 and we take x plus 2, and we take the 2 also, all of them as a common factors. There are 3 common factors here. 2 is a common factor, x minus 1 is a common factor, x plus 2 is a common factor. Now inside we have x plus 2 plus x minus 1, which will be 2x plus 1. So now the product will be all f prime. Critical values we have, f prime is equal to 0, x will be 1, x will be minus 2, x will be minus half if you put this one is equal to 0. X-intercept, let y is equal to 0, so we can put the whole function equals to 0, so x will be 1 and minus 2, the x-intercept. Now let's look at this nice, big, huge table of signs because we have 3 critical values. So we have to make it a little bigger. Okay, so we put x minus 1. This is f prime, x minus 1, x plus 2, 2x plus 1. Take a number there between minus infinity and minus 2. Take a number between minus 2 and minus half. Take a number between minus half and 1. Take a number between 1 and infinity. And you try it in every factor here. So when you multiply 3 minuses, you get a minus. F prime is a minus, the function is decreasing. F prime is a plus, the function is increasing. Here we have minimum, here we have maximum, here we have minimum. Please check all the signs. And then let's see the graph now. Look at the nice graph. This is x minus 1 squared, x plus 2 squared. This is a tangent here at 1, and this is a tangent at minus 2. So we have a local max, but we don't have a global max. We have local max because the function here is going up to infinity. But here we have local minimum, and these local minima, they are global minimum here at minus 2, 0. We have a global minimum at 1, 0. The x-intercept is there. And then we have f is decreasing here, c minus infinity to minus 2, from minus half here until 1, increasing from minus 2 to minus half, all increasing, and then from 1 up to infinity. So everything you need on this graph. For more questions on simple curve sketching, you can see lecture 18. And for more questions on Calculus 1 in general, you can visit the playlist Calculus 1 Solve Questions. Thank you for watching. If you like the video, you can subscribe and share it with your friends. I hope I can see you in another video with another topic. Thank you guys for listening.